Our last lesson on Unit 1 is called Function Notation, and you really already know how to solve these. It's just another way of looking at your functions, something you're probably not used to. So to start, what I want you to do is pause the video and try this problem, and then check it with me. Okay, so for y equals 3x minus 2, the first step is saying to find y when x is negative 1. So what we're going to do is we're going to plug in negative 1 for x. Now to find y, you should already know how to do this. We're going to use PEMDAS, or order of operations, to figure out what y is. So first, 3 times negative 1 is negative 3. And negative 3 minus 2 tells me that y is negative 5. So for this, I want you to think about a coordinate. And remember coordinates, you always write x first and then y. If I were to write the coordinate that we just found, when x is negative 1, we just found that y is negative 5. This is really important for this lesson to understand the difference. X, negative 1, that is your input. Y, negative 5, that is your output. So get in the habit of thinking about x as input, y as output, because that is very important for this lesson. Now, the second question is the opposite. Instead of saying find y, this question is asking you to find x. So in this case, it says find x when y equals 13. I'm going to rewrite our function here. And now, instead of plugging in for x, since I know what y is, I'm going to plug 13 in for y. We're no longer using order of operations. You're now having to use your solving steps to get x by itself. So your first step is to add 2 to the other side. And if 15 equals 3x, then when I divide the 3 out, I find that x equals 5. Again, if you think about this as a coordinate, I would write this as 5, 13, because we always write x first and y second. In other words, I was given the output, I knew the output was 13, and then I found that the input was 5. This is basically all of the math steps that you're going to be doing today, but instead of using y, we're now going to use function notation. So it's going to look something like this. If you notice, I have given you the exact same function that we had on the previous slide. So this function has not changed. Instead, I have written it in function notation. So when you look at this, f of x, that is just a fancy way of saying y. Just like you and all of your classmates have different names, our functions are now going to have different names. It's a way for us to tell them apart. So this one is called f. We have f of x. Do not say this as fx. It is, those parentheses would make it f of x. So the first part of this problem says find f of negative 1. Whenever it is written like this means they have given you your input. And the way I remember it is in the parentheses means input. So in other words, if I think about this as my coordinate, I know that x is negative 1. I'm missing my output. I don't know what y is. So to find f of negative 1, I'm going to replace x with negative 1. So f of negative 1 is 3 times negative 1 minus 2. Be very careful when you're looking at this. This f of negative 1, that does not mean f times negative 1. That is the name of our function. That is the name of the point we're finding. So you're actually not going to do any work on the left side here. Instead, we're going to multiply 3 times negative 1. And negative 3 minus 2 tells me that f of negative 1 equals negative 5. We're now finished. What we just found is that when our input is -1, our output is -5. So the input is -1, the output is -5. The work is the exact same that we did previously. It just looks different because instead of y, we're now using f of x. Let's look at the opposite situation. On the second part, it does not give us the input. Instead, it has given us the output. So it says find x. We don't know what x is when f of x equals 13. So to do this, I'm going to rewrite my function. And in this case, I don't know what x is, but I know that f of x is 13. In other words, y is 13. So this 13 is out of the parentheses. It's not my input. So instead, this time, I'm going to replace f of x, that whole thing, with the 13. Since it says find x, I need to get x by itself. So I'm going to add 2 to both sides. And then I'm going to divide by 3 to find that x is 5. Again, if I think about this as a coordinate, what I just found is that when my input is 5, my output is 13. So the input is 5, output 13. When you compare this to the work we did before, the solving steps are the exact same. Again, it just looks different because we're using f of x instead of y. So let's compare the two side by side. You are used to seeing equations with y equals. You're used to seeing a question that says, what is y when x is 3? Today, what you're seeing is the exact same. It's just written in now function notation. So your equation is the same, but instead of y, we're using f of x. And then instead of just saying x equals 3, you're now going to see f of 3. Remember, in the parentheses means it is your input. Another recap here is that with function notation, f of x is the same thing as y. You'll now see f of x. You might also see g of x or m of x or t of x. It's a way for us to tell different functions apart. You might be asking right now, why do I need to know this? In Algebra 1 and moving forward in math, you're going to be given problems that have multiple functions in one problem. If we named them all y, it would be really hard to tell them apart. So just how I tell you apart from your classmates because of your name, we're now going to name our functions different letters to help us tell them apart. Just remember that x is still your input, f of x is your output, it is your y. So here's your first example of something you will see when you're given multiple functions. I have given you f of x, which is negative 4x minus 3, and then I have given you g of x, which is negative 1 plus 2x. It's very important that you know the difference between f and g. Number 1 says find f of 2. So that f there is telling me that I want to use f of x for this problem. So f of 2 is in the parentheses, means that I am going to plug in 2 for x. Since 2 is in the parentheses, it is my input, so it is x. Now I'm going to do order of operations. Negative 4 times 2 is negative 8. Negative 8 minus 3 is negative 11. So what I just found is that f of 2 is negative 11. In other words, when x is 2, y is negative 11. Moving on, I'm going to skip number 2 for right now and go to number 3. Number 3 is still using f, but this time 21 is not in the parentheses. This time it says f of x equals 21. So in this case, I'm going to replace f of x with 21. We don't know what x is, so we have to get it by itself. So first step is to add the 3. Next step, to get rid of the -4, we're going to divide it. So x equals -6. In other words, if I wanted to write this as a coordinate, when x is -6, when my input is -6, my output is 21. We were given y, so we found x. Moving on to number 2. Number 2 says g of -5. So this time I'm using g of x. G of -5, since -5 is in the parentheses, means I am going to plug in -5 for x. Now to solve this, I have to do order of operations. So 2 times -5 is -10. And -1 minus 10 gives me -11. So what I just found is that for the function g, when my input is -5, my output is -11. In other words, y is -11. And then finally for number 4, it says g of x equals -7. I'm going to replace g of x with -7. And then I'm going to solve for x. This time I was given my output. I'm looking for my input. So to get x by itself, I'm going to add 1 to the other side. And then I'm going to divide by 2 to get -3 for x. If I wanted to write this as a coordinate, when x is -3, my output, or y, is -7. It's really important that you understand the difference between input and output here. Remember to pay attention to both which function you're dealing with, so what letter you're given, and then if you're given something in the parentheses or out of the parentheses. The last thing you're going to see for this lesson is function notation on a graph. So it's very important that you remember that x comes before y. In other words, you have x, and then with function notation, in this case we're using h of x is your y. So starting with number 1, 2 is in the parentheses. So if you wanted to think about this as a coordinate, I have the x value. What I need to now find is the y value. So what I'm going to do is look at my graph, and I'm going to find where x is 2. In this case, x is 2 right here, and this time it happens to fall straight on our curve. So at that point, when x is 2, I know that since I didn't move up or down at all, y is actually 0. So since I have the point 2, 0, when my input is 2, my output is 0. Same thing with number 2. It says h of 4. So I'm going to go where x is 4. I've been given the input. Remember, this graph, if you look at it, is going by 2's. So when x is 4, which is right here, I can look on my curve and see that I'm way up here at positive 12. I have the point 4, 12 on my graph. So when x is 4, when my input is 4, my output is 12. Number 3 is very similar, except number 3 we're using -6. So if you go to where x is -6, right here, you can see that I'm hitting my curve way down here at -8. So when my input is -6, my output is -8. So that would be my answer for number 3. Number 4 switches gears a little bit. Number 4, instead of giving us the input, number 4 has now given us the output. Since 0 is not in the parentheses, it is out of the parentheses, we now have our output. So this first one says h of x equals 0. In other words, we're trying to figure out what x is when y is 0. So if I look at where y is 0, here's where it gets a little bit tricky. If you look at where y is 0, I actually cross that 1, 2, 3 times. And you want to include all 3 points. So I have a point -4, 0 right here. I have the point -2, 0 right here. And then I have the point 2, 0 right here. So my answer has 3 parts. I have -4, -2, and 2. Since we were given the output, we had to find the input. Moving on to number 5, it's very similar. We've been given the output. This time the output is -2. So I'm going to look at where y is -2 here. If you look, I have a point here. I have a point here. And technically one more here when it goes back up. So since this is going by 2's, this first point is at about -5. This second point would be at 0. And this third point is at about 1. So x is -5, x is 0, and then x is 1. It would be a good idea for you to pause the video and try number 6 on your own and then check it with me. Okay, for number 6, the output we are given is 4. So when you look at this, I'm only crossing 4 right here at this point. So when y is 4, my x value, it looks like, would be 3. Remember, our graph is going by 2's, so in between 2 and 4 means that that's about 3. That's all we're going to cover today for function notation. Make sure you remember the difference between the input and the output. And then remember, you already know how to do this math. It just looks a little bit funny because you've never seen function notation before.